Hi students, now we are going to solve some of the very important MCQs in the chapter magnetic effects of electric current and also magnetism. Problem number 1. The Earth's magnetic field at a certain place has a horizontal component of 0.3 into 10 power minus 4 Tesla and the total strength 0.5 into 10 power minus 4 Tesla. So the angle of dip has to be determined. Yes, sir, we have studied the magnetic elements of the earth, is it not? So there are three important magnetic elements of the earth. What are they? The angle of declination, the angle of dip and the horizontal component of the earth's magnetic induction. Okay children, now what are the given quantities? First we will write the horizontal component. So it is given BH for horizontal. So BH is equal to 0.3 into 10 power minus 4 Tesla. And the total strength of the magnetic field. So B of the earth, I will take the symbol B suffix E for earth, Earth's total magnetic field. And that is given as 0.5 into 10 power minus 4 Tesla. Here, the vertical component is not given. First of all, we must know. Secondly, the relationship between these two can be written as the horizontal component BH is equal to the total strength of the magnetic field BE into cos of theta. So this is the expression which is required here. So these two quantities are given. From this what we can determine is theta. So theta is called as what? Theta is called as the angle of dip. So first we must write this step. We have to determine what theta. Is it not? Okay. So for this what I am going to do is substitute and find the value of cos theta first. So from this cos theta is now equal to BH divided by BE. So BH divided by BE. So what is the horizontal component? BH is 0.3. So this is 0.3 into 10 power minus 4 divided by 0.5 into 10 power minus 4. So cos theta is now equal to 3 by 5. Okay, 3 by 5. So theta must be what? Cos inverse of 3 by 5. There is one method directly. Suppose if you are unable to remember the value of cos inverse, suppose standard value like 1 by 2, cos inverse of 1 by 2, 1 by root 2, root 3 by 2 and all we remember. But for 3 by 5 cos inverse we do not know. So for that another method we can go. So cos square theta, I will write cos square theta is equal to 3 by 5 whole square. So this is equal to 3 square by 5 square and that is equal to 9 by 25 cos square theta. So 1 minus cos square theta is equal to what? Sin square theta. So sin square theta is equal to 1 minus cos square theta. Therefore sin theta is equal to, so what is sin theta is square root of 1 minus cos square theta. So sin theta is equal to square root of 1 minus 9 by 25. So 1 minus 9 by 25. So this is equal to square root of 16 by 25. So LCM is 25. 25 into 1 is 25. 25 minus 9 is 16 divided by 25. Both are square numbers. So what is the square root of 16 is 4 and square root of 25 is 5. Okay, therefore now we get the value of sin theta is equal to 4 by 5. Already cos theta is equal to 3 by 5 we are having. And here sin theta is equal to what? 4 by 5. So I want to find tan theta. So what is the tangent value of theta? This is equal to sin theta divided by cos theta. So this is equal to sin theta is what? 4 by 5. Is it not? So this is 4 by 5 divided by cos theta is 3 by 5. So this 5 get cancelled, is it not? So this is equal to 4 by 5 into 5 by 3. So 5 get cancelled, therefore tan theta is now equal to 4 by 3. Okay. Therefore what is theta is now equal to tan inverse of 4 by 3. So this is the required answer. We have got the angle of dip. So what is theta? Theta represents the angle of dip. That only is asked. The angle of dip is. So tan inverse of 4 by 3. Option A itself is the right answer. Is it not? Therefore, so which option is tan inverse of 4 by 3? That is option A. Therefore, option A is the correct answer. So, without the need for the vertical component, we have determined this is one method. This is one example only. Like this, different pattern of problems in the same concept, angle of dip. Many types of numerical problems we are going to solve in the subsequent videos. Okay, I hope you must have understood well. Fine.